Now, suppose we have a line in a Cartesian plane. Okay. Now, this line is formed by joining 2 points, A, whose coordinates are x1 comma y1, and B, whose coordinates are x2 comma y2. Okay. Now, if there is a third point P, x comma y, which divides the line AB internally in the ratio of m:n. That means AP by PB is equal to m by n. This is called as section formula for internal division. Internal division. So section formula for internal division. So P divides A and B in the ratio m:n internally. So the result is Pxy is m times x2 plus n times x1 by m plus n, and m times m is this division, so m times go to the other point y2 plus n times come to this point y1 by m plus n. Okay, this is x and this is y, and this is the line. This was the point P x1 comma y, A x1 comma y1 and B x2 comma y2. All right. Now this is a point P in between with coordinates x comma y. I have to find out what are these coordinates x comma y. So for this, what I do, see this, I drop perpendicular from A onto the x-axis. I drop a perpendicular from B onto the x-axis. Okay, it's not exactly there because of, all right. Next, I also drop a perpendicular from P onto the x-axis, and I draw horizontal lines from A from P. All right. Now let this point be A dash, let this point be P dash, let this point be B dash, and let this be C, let this be D. Now just observe this. Now this distance, what is this distance? Anybody? You can answer. Unmute yourself and answer. What is this distance? X1. Very good. This distance is x1. And what is this distance? OP dash. OP dash. This distance will be x. This distance is x. All right. And what is this distance? OB dash.
x2. x2.
X2. Very good. So because coordinate of B is x2. So B dash, this is a vertical line. So this horizontal distance will be x2. So coordinates of B dash are x2 comma 0. So this distance is x2. Likewise, what is this distance? C B dash. What is this distance? Anybody?
y1.
Y1. Very good. What is this distance? B dash to D?
y
Y. And this distance?
y2.
Y2. Good. So now, what I want is the coordinate of X and coordinate of Y. Now, if I look at this line, AC with this point, okay, what is this distance? P double dash, let's say AP double dash. What is this distance? Up to here, the distance is X. All right, correct? And up to here, distance is X. And up to here, distance is X1. So this will be X minus X1. Correct? Now, and this distance will be X minus, sorry, this one will be X2 minus X. Similarly, this distance CD will be Y minus Y1. And this is Y2 minus Y. Now, what is happening? By we know that AP, P is dividing AB in the ratio M is to N. AP by PB is M by N. By similar triangles, if you consider this triangle, BAC is one triangle, and you know AP double dash, this is another triangle. These are similar triangles. So based on similar triangles condition, if this AP by PB is M by N, this AP double dash and P double dash C will also be M by N. So this is also M is to N division. Okay. So if this is M is to N division, then it becomes easy. Then we can write, you see this distance will be this particular distance, just AP double dash. X minus X1 will be equal to, of this total distance, this will be M by M plus N times AC. This is by ratio proportion. AC is M plus N. AC is some length, and this total length is M plus N. And this is M. So this particular distance will be M by M plus N times AC. So you get X minus X1 is M by M plus N times, what is AC? X2 minus X1. Okay, so now what will be X? Bring this X1 to this side. Then you simplify this. You multiply M plus N with, you bring multiply M plus N with X1 and bring to a common denominator. So M plus N times X1 plus M times X2 minus X1 by M plus N. So you get X as, now you expand, mx1 plus nx1 plus mx2 minus mx1 by m plus n. What happens? mx1 cancels. Then you are left with mx2 plus nx1 by m plus n. So that's what is the x coordinate. If you go back, this was our x coordinate, mx2 plus nx1 by m plus n. So that's what we found here. This is x. What did I do? Simple ratio proportion, that's all. Okay. Now similarly, I will repeat for y so that if you didn't understand for x, you will understand for y. Now again, you see these triangles BAC and BPD are similar triangles. So if this division is n is to m of this line PA, P divides m n is to m, then D will divide BC in the ratio n is to m again, because of similar triangles. So now again I will write here this first, I will write for y here. So this y minus y dash, or the CD, is y minus y1, sorry, y minus y1 CD will be m by m plus n times the total length CB. Correct? Total length CB is this is m is to n. So total length, if it is m plus n, this is m. So this length will be m by m plus n times CB. Basic ratio proportion. Now what is CB? M plus m by m plus n times CB is y2 minus y1. Correct? Look here. CB. To B it is y2, and this B dash B is y2 and B dash C is y1. So y2 minus y1 will give us CD. All right. So now you simplify. So from here, y will be equal to y1 plus m by m plus n, y2 minus y1. I'll write this as m plus n times y1 plus m into y2 minus y1 by m plus n. Okay. M y1 plus n y1 plus m y2 minus m y1 by m plus n. Okay. So what cancels? M y1 and m y1 cancels. So you have y will be m y2 plus n y1 by m plus n. This is what we had found, we had written earlier. Okay. This one, m y2 plus n y1 by m plus n. So this is the section formula for internal division. You have to remember, at some point of time I will tell you how to remember formulas, how you should memorize formulas, how you should make a formula list. At some point I'll tell you. And one more thing, this calculations I did very slowly because you are first year students. I'm not presuming that you all are very fast in calculations. You are in class 11, but with practice I would actually write, after this step, I will directly write this step. Okay, I will not go through these steps. So with practice, maths is something that the best of teachers can teach you, best teacher in the world can teach you. However, unless you practice yourself, you will not get grips to it. So to increase your calculation speed, you have to practice. So anyway, so this was moving forward. So this was the section formula for internal division. Now we'll write section formula for external division. If just a second. External division. What does external division mean? Okay, this we can again derive, but I'll not derive, I'll directly write. So P x comma y divides the join of A x1 comma y1 and B x2 comma y2 externally in the ratio m:n. Sometimes this is written as, instead of writing external division, we write it as minus m:n. It means that the ratio is negative. That means it's an external division. What does external division mean? So let us say this is the join. This is the point A, x1 comma y1, and point B, x2 comma y2. Now external division means that the point P lies on the line. I'll extend the line. So the point P lies on the line, but not in between A and B. Okay, here AP by BP is m by n. If you see the distance wise, AP by BP will be m by n. However, P doesn't lie between A and B. That is the point. P can be either to the right of B or to the left of A. Doesn't make a difference. In both cases, so exactly the same approach as we did previously. Instead of having P point in between, P is outside. I would want you to try to solve and get this formula. I am directly writing the result. So P x comma y will be mx2 minus nx1 by m minus n, and my2 minus ny1 by m minus n. This is the formula for external division. Now you may say, can't I write minus m and plus n? Does it make a difference if P is on the right of B or the left of A? It doesn't make any difference, because whether you take m negative or you apply either negative sign for m, positive sign for n, or like this, positive sign for m and negative sign for n, it is the same. Here remember m and n here are positive values. Okay, when I say minus m is to n, m and n are positive values, and this negative sign in between is a must. This is the formula for external division. Okay, now a few results. Very important result, very common result in coordinate geometry. Midpoint. Midpoint, let's say midpoint is M of line joining A x1 comma y1 and B x2 comma y2. So midpoint of AB M, midpoint M is, midpoint of AB. You all know this result from class 10th also. So MXY, the midpoint, is x1 plus x2 by 2 and y1 plus y2 by 2. This is the midpoint. Another way to look at midpoint is using section formula. Just a second. This is point A, this is point B. Okay, this is x1 comma y1, this is x2 comma y2. So the midpoint M, this divides AB in the ratio 1:1. Okay, so it divides, midpoint is exact division, exact center point. So it divides the line joining AB in the ratio 1:1. So in our section formula for internal division, this is the section formula for internal division. M and N are 1 each. Okay, so what do you get? 1 times x2 plus 1 times x1 by 1 plus 1. So you get x1 plus x2 by 2. And here M is 1, N is 1. So 1 times y1, y1 plus 1 times y2, y2. So y1 plus y2 by 2. So that is the formula for midpoint. Next, formula for point of trisection. Point of trisection. Let's say that point is P of line joining AB. P is a point which divides AB in the ratio 1:2 or 2:1. There are 2 points of trisection. So I'll write this point as P and this point as P dash. There are 2 points of trisection. So it is a point that divides AB in the ratio A is x1 y1, B is x2 y2. So line which divides the point P divides the join of AB in the ratio 1:2 or 2:1. So there are 2 points of trisection. So the point of trisection formula, just look here. So Pxy will be again 1 times x2 plus 2 times x1 by 1 plus 2, 3. Okay, m times x2 plus n times x1 by m plus n. Next, 1 times y2 plus 2 times y1. So y2 plus 2 y1 by 2 plus 1, 3. The second point of trisection in 2:1 ratio will be 2 times x2 plus 1 times x1 by 2 plus 1, 3. Again 2 times y2 plus 1 times y1 by 2 plus 3. So 2 plus 1, so 3. So these are the points of trisection.